So we're going to start today's lesson talking about physical and chemical changes. So in the previous videos, we talked about the physical and chemical properties. Now we're going to talk about how we can identify physical and chemical changes. Now, the most obvious way of observing a physical change is that it involves a change in its state, so remember solid, liquid, or gas, or form of matter. So for example, you see the pictures here, we're dissolving salt in water. Now, it's still salt and water. We could technically separate the salt and the water if we evaporated the water. We really haven't created a new substance here. If you look at the ice cube melting, it's still water. It's just going from a solid to a liquid state. Same with breaking glass. It's still glass, it's just in many little pieces. And of course, if we had the patience, we could sit there with super glue and try to put all those pieces together and make it back into the whole glass. So it's just changing its state or form. We haven't created a new substance when it comes to a physical change. Now, with a chemical change, we actually create a new substance. I love the picture in the fireworks, right? We've all seen fireworks at some point in our life, either in person or on video. And what happens is that you have a mixture of chemicals inside the firework case. And when you light it and add heat, what happens is a chemical reaction takes place. And the interaction of those chemicals together with the heat causes those beautiful explosions of color. Same with frying an egg, right? When we fry an egg, it's a new substance. We can't go back. We can't take this fried egg and do something and return it to its original raw egg, right? Or if we create a new substance, it's almost impossible to take that new substance and return it back to its original state, or not state, original substances that we started with. So we have actually a list of things that usually show or give an indication that a chemical reaction has taken place. We're looking at the diagram here that has this yellowish cloud that is forming in the beaker. So what's happened here is we've had two liquids, and we pour one of the liquids into the liquid that's in the beaker. And as those two liquids meet each other, they react, forming what we call a precipitate. And that is when a solid is formed when two liquids are mixed together. And it's obvious here that a reaction has taken place because we have a new substance, the precipitate. And here are the main signs. Of course, this is not all encompassing, but these are the major signs that a chemical change has taken place. Energy, light, or heat is released or absorbed. So if there's some sort of big bang or explosions and release of heat, such as with the fireworks, right? That is an indication that a chemical change took place. A color change. So if we look at the egg, right? An egg white, when it's raw, is clear. When you cook an egg white, it becomes a opaque white substance. So that's an indication of a color change. Bubbling or indicating gas formation. And what that means is if you mix two things together and you start seeing bubbles form, well, that's an indication that a reaction is now taking place. And when a gas is released, that means a new substance is formed. Precipitate, and I'm actually going to go back to the previous slide so you can actually see an example of this. And then finally, the most common indication of a chemical change is when we find it very difficult to reverse the change. Okay, so for example, fireworks. Once the fireworks explode, we can't take the things that are in the air and pack them back together and create another firework. It's impossible. Same with, for example, cooking an egg. Once the egg is cooked, that's it. You can't go back and recreate the raw egg. So try to keep those things in mind when you're trying to determine a physical or a chemical change. The physical change means it's just a change of state. The chemical change is the sign that we can't reverse it. And we have the list here of some of the indications about how we can identify a chemical change.